In this video, I'm going to teach you about piecewise functions. And to begin with, I have given you a function called f of x, and it has two pieces to it. So in a piecewise function, you can have as many pieces as you want, and each piece has its own domain. So on these two pieces, you can tell that you have two linear functions. This x plus 4 function we know has a slope of 1 and a y-intercept of 4, and it's actually going to go on forever towards the left, but then it's going to have an endpoint when it reaches the x value of -2. And then for the other piece, which has a negative slope, it has an endpoint on the left side, and it will go down towards the right side forever. So we just need to find out where those pieces are going to go on this graph here. So to begin, I always like to start with the endpoints. So let's see, for this one right here, I know that it's going to end at -2. Let's find its y value. So when x is -2, we get a y value of 2. So there's going to be an endpoint at -2, 2. And notice that that is a bracket, which means we're going to actually include the point -2, 2 in our domain. So I'm going to give that a closed circle. And remember I said this has a slope of 1, and it's going to look, whoops, it's going to look something like this. So I'm going to give it a slope of 1. And that piece is done. All right, I'm going to get rid of this work so I can work on my second piece. And in my second piece, we will have an endpoint at -2, but notice this one has a parenthesis, which means that's going to be an open circle. So when I substitute -2 in for this function, I wind up getting, let's see, 2 minus 1 is 1. So this one has an endpoint at -2, 1, but this time it's an open circle. We don't want to include that point in this part of the function. And this has a -1 slope. So it looks like that. And that was our first piecewise function. So in the next example, I've given you a graph of a piecewise function, and I want to come up with the function to describe it. So I'm going to call it g of x just to be different. And we know we're going to have two pieces, and each of those pieces is going to have a domain. So think about having those four things filled in. So our first piece, I like to start at the left side, is this right here. So to me that looks like a line with a slope that's definitely negative. I'm thinking that it has a point right here. So maybe a slope of -3. So I'll say -3x. And its y-intercept is at 1, so I'll put +1. So there was just easy slope-intercept form. And its domain, let's see, it goes all the way from the left, so that's from -infinity. And it goes up to, let me erase this so I can see it a little better. It has an x value right here of 1, but it does not include it. So I'll leave it as -infinity to 1. And then this piece here, this one, this has a slope of 1, but notice that its y-intercept is not there. But if you were to keep it going, it looks like it would be a 5. So I could say x plus 5, and that has a starting point at 1 and goes all the way to infinity. But I just want to talk for a second about how you would find this if you didn't notice right away that the y-intercept was going to be at 5. So let's talk about this graph in point-slope form. So we know that its slope is 1, and we know that a point on this graph is 1, 6. So if I made point-slope form, I'd say y minus 6 equals 1 times x minus 1. And then if you just change this into slope-intercept form, you'd get y equals x minus 1 plus 6, which brings you back to the y equals x plus 5. And now to finish up our video, I thought I'd give you something that has 3 pieces, and those pieces are a little bit different than you're used to, probably. So the first piece is a line, and I'm going to find its endpoint right here. So when I substitute in -2, I get 2. So this has an endpoint at -2, 2. And it had a slope of 1. Remember, it was coming from the left side. So that's our first piece, and it's just like the other pieces we've done. Now let me get rid of this stuff, and we can talk about the second piece. So here's our second piece. I'll use red. So when you see y, or f of x equals 6, you should know that that's a horizontal line. But notice that we don't have a horizontal line in forever in both directions, right? So I'm going to put an open circle at -2, 6. Right? So at -2 we get 6, and at 1 we would also get 6. So because those both have parentheses, we're not actually including them in the domain there. So we get that right there. And then our last piece, we have this quadratic, and it has an endpoint at 1. So when I square 1, I get 1. So we have a point at 1, 1. And if you're not sure how to graph x squared, just make a table, right? So if I plug in 2 and I square it, I get 4. So there's a point at 2, 4. And if I plugged in 3, I'd get 9, and so on. Alright, so there's our 3-piece piecewise function.